Hi. Okay, so we're looking at geometric growth and decay. Previously, we'd looked at linear growth and decay. So we can see this growth here. It doesn't go up by the same amount each time. Look at the first one. The rule is multiplied by 3. So 1 multiplied by 3 is 3. So that one's actually gone up by 2, hasn't it? It's gone up by 2. This one here, 3 multiplied by 3 is 9. So that one's actually gone up by 6. Doesn't go up by the same amount each time. So it's geometric growth. But there is a rule. It's still a rule, multiplied by 3. Look how they've written it, 3 times Vn. This one here is decay. So these ones are getting smaller. So this is multiplied by 0.5, which is just the same as half. So if we half 8, we get 4. So that one's gone down by 4. If we half 4, we get 2. So that one's gone down by 2. So again, it's not going down by the same amount, but there is a rule there that we can work out. So we know the rule, it's just not going down, it's not linear, it's geometric. So look how they've written it. Starts off at 1, rule is times 3. Starts off at 8, rule is times 0.5. You use these sort of things for interest, depreciating of a car, all sorts of things like that. So 3 and 0.5. What do you notice about those numbers? 3 is greater than 1. 0.5 less than 1. It's a fraction. So if it's greater than 1, it's growth. If it's less than 1, it's decay. So if R is greater than 1, growth. R is less than 1, decay. So as we mentioned, simple interest is your linear. Compound interest is your geometric. So we looked at simple interest where you just add $100 each year. Compound interest is where you add a certain percentage each year. So the value will change each year. So we'll look at things like loans, investments. So here's the rule. So here we have 1 plus R over 100. This is our geometric growth. It's a plus, so it's growth. If it was minus, it would be the decay one. So same, V0, still the principal. The next one, so Vn plus 1, the next term is R, which is our rate, times by Vn. Okay, so it's not that different. This is geometric growth. So geometric growth is this one. So let's look at an example. Following relation can be used to model a compound interest $2,000, 7.5% per annum. So 2,000, we know where that 2,000 comes from. Where does that 1.075 come from? Well, it comes from here. 1 plus R over 100. So 1 plus 7.5 over 100. Do that on your calculator. 1 plus 7.5 over 100, 1.075. So that's where that comes from. We can use that to find the value after 1 year, 2 year, and 3 years. So after 1 year, we just do the original amount, 2,000 times 1.075, gives us 2,150. Because we're using compound interest, we take this value and reuse it to give us this answer. We take this value, reuse it there to give us the new answer. Okay, so it's not the same amount every year, but it is the same percentage every year. Determine when the value will exceed 2,500. We can see it's nearly there, so it's probably the next year, but let's just double check. And we could have done this question using this calculator method. So you just type 2,000 into your calculator, make sure you press enter. Then do 2,000 times 1.075. That gives you, that's after 1 year, which is the same as that one. 2 years, same as that one. 3 years, same as that one. 4 years, that's where it's over 2,500. After 4 years, exceeds 2,500. Write down the recurrence relation if 1,500 was invested at an interest rate of 6% per annum. So we have to do 1 plus 6 over 100, which is 1.06. So V0, 1,500, Vn plus 1, 1.06 times Vn. Easy. Or is it? Brian borrows money from a bank, 5 grand. He's going to pay interest of 4.5%. Write down the recurrence relation. It's done yearly. So per annum means per year. So at the moment, it's 4.5% per year. So all we need to do here is 1 plus 4.5 over 100, 1.045. V0 is 5,000. From here, we've just worked out, so that's 1.045. So Vn plus 1 equals 1.045 times Vn. What happens if you do it quarterly? If it's quarterly, we have to we're going to do it 4 times in a year. Yeah, there's 4 quarters in a year. So we have to divide the interest rate by 4. 4.5 divided by 4 comes to 1.125. Don't forget to do this. Lots of students all around the world forget to do this bit. So we've worked out, all we've done here is worked out what the quarterly interest rate is. We still have to do our 1 plus r over 100. 1.01125. So there's our new relation. If we do it monthly, we have to divide by 4. Sorry, not by 4. What am I talking about? We have to divide by 12, don't we? So 4.5 divided by 12. And again, don't forget to do this bit. Now the numbers are getting quite small here, isn't it? 1.00375. Take care with that, because lots of people will get the zeros wrong or not put the zeros in, so take real care with that. So flat rate and unit cost were linear. They go down by the same amount each time. When things go down not linear, using geometric, it's called reducing balance depreciation. And we have a minus here. So just have a minus here instead of a plus. So everything else here is the same as when we've got compound interest. We've just got a minus here because it's depreciated. That's geometric decay. So each year it's going to be reduced by a certain percentage. It's not necessarily going to be the same amount, it's going to be the same percentage. So here's an example. Office furniture starts off at 6,900, reduces by 9% per annum. V0, 6,900, 6,900, easy to work out that, but where the hell does that come from? Where the hell do we get 0.93 from? This is important. You have to remember how to do this. You have to be able to do this. So remember, we've got capital R equals 1 minus little r over 100. Little r is the interest rate. When we turn that 1 minus r over 100, that's where we get our 0.93 come from. So this is an issue that kids forget. So make sure you're not one of those kids that forgets. So use a recurrence relation. So again, I'm going to quickly, that's the way to put it. It's probably easier just to go straight to the calculator. 6,900, press enter, and do 6,900 times 0.93. That's after 1 year, that's after 2 year, that's after 3 year. 1 year, 2 year, 3 years. Determine when it's less than 5,000. So it's still 5,000 there, still 5,000 there. It's less than 5,000 there. So it happens after the 1, 2, 3, 4, 5th year. So after 5 years. Write down the recurrence relation. The furniture was 7,500, depreciates by 8.4%. Well, that's easy, 7,500. Just where do we get the 0.916 from? We do 1 minus 8.4 over 100. That's where we get that from. Sure you won't make the mistake again. 8.4% becomes a depreciation of 0.916. We'll just do that. 1 minus 8.4 over 100. That's what it looks like if you do it on your calculator. Geometric relations. So growth, compound interest, decay, reducing balance depreciation. That's what they'll be called in the questions. Yeah? That's the growth because we've got a plus there. That's the decay. We've got a minus there. There's some videos for you to watch. So pause this now. Go to the chapter 8 information folder on Google Classroom and open up the PowerPoint, and then you can actually play these videos. So I'm not going to play them now. It's one on compound interest, another one on compound interest, and one on reducing balance depreciation. There's some work for you to do. If you want to open up this, again, if you go to the PowerPoint, you can open up that little connection. I think it's an Excel spreadsheet. It tells you what happens, what can happen with $1,000. Good luck.